In our previous video, we looked at vectors in general, and we saw the difference between the vector and the scalar. Now, we're going to look at addition of vectors. So, let's do it. Here. First of all, you remember, when you add two numbers, the answer that you get, you call it the sum. But when you add two vectors, what you get for your answer is called the resultant. The resultant is the answer. Now we're going to add two vectors. But just before we do that, you remember each individual vector is drawn like this. But when you draw the resultant, you draw it like this. You put two arrows on the resultant to show it different from the individual vectors that you added to obtain that resultant. Now, we're going to add two vectors that act in the same direction. Looking from upstairs, looking downstairs on the auditorium, you are pushing this table. You're attempting to push the table in this direction. You want the table to go this way. One of your friends sees you pushing, and you're pushing with a force of 50 pounds. Your friend comes here to help you push the table. Your friend is pushing with a force of 40 pounds. Now you're going to add these two vectors. This vector represents your force of 50 pounds. This other vector represents your friend's force of 40 pounds. The question is, what is the total force on the table? Let us see. You have 50 pounds plus 40 pounds. Remember, the length of the vector tells us its strength, its magnitude. 50 pounds and 40 pounds. What you must do now is this. To get the total force, you must add the vectors. You could add it this way and say 50 pounds plus 40 pounds is equal to 90 pounds. But to show what you did, you must show the vectors. This is your 50-pound vector. What you must do now is add the 40 pounds to it by drawing them following each other. You see that? Now remember, you have one complete vector with 50 plus 40 giving you 90 pounds. This is the resultant. So what you must do now is draw two arrows on the resultant. There you are. You have a resultant of 90 pounds here. You see that? You could consider this vector and this vector. If you call this vector AB, then you call this vector CD. When you add them together, what you get is this. Vector AB will look like this. A B. You see that? What about vector CD? Vector CD is this. So all of this vector, this long vector here, if you consider only the end numbers, you can consider it as vector A, D. Remember, it points in this direction. This is the resultant of these two other vectors. So therefore AB plus CD is equal to AD. Remember your arrows to show that these are vectors. So that is what you have. These two vectors are pointing in the same direction. Now, let us look at this scenario. What if this person is really not your friend? Not your friend at all. He's an opponent trying to push the table in the opposite direction. But pushing with a force of the same 50 pounds. I sometimes use Newton because that is the SI unit you use in physics. But I'm going to use pounds in this diagram. I'm going to continue using pounds. 50 pounds acting to the right and 50 pounds acting to the left. Now, here, what would be the resultant? Let us see what would happen. Let's erase this. Oh, no. I don't want to erase this part here with the working. But let us see what's going on in this case. In fact, I'm going to draw your friend vector in red. Here now you have 50 pounds to the right and 50 pounds to the left. You're adding vectors going in opposite direction. What you're really doing here, when you add a negative number, you are subtracting. So, you're really subtracting one vector from another. Let us say this vector is vector AB. B should be here. And this here is vector CD. Now here, you're subtracting. And at this point, these vectors meet. You can see that the 50 pounds acting to the right added to the 50 pounds acting to the left is like saying 50 minus 50. And what do you get for that? Of course, 0. They both cancel out. So the table will remain, it will not move. It will behave as if no force was pushing on it. These equal and opposite forces cancel each other. Do you see that? Now, suppose you muscle up some more. You put in a bit more muscles and you push this table with 55 pounds of force. So this vector gets a little longer. So we have 55 pounds of force. This is no longer 50 pounds. It is now 55. So look at what happens with the vectors. The vector to the left will get a little longer. 50 pounds off this vector will be cancelled by 50 pounds off this whole vector and leave this. That will be left over. How much is it? It will be 5 pounds acting in to the right. Because, of course, 55 minus 50 is equal to 5. Now at this point, make a note. Vectors acting to the right are considered positive. Vectors acting to the left are considered negative. Vectors acting up are considered positive. Vectors acting down are considered negative. It's somewhat like the xy coordinates, where you have 0 at the center. Positive numbers go to the right, negative numbers go to the left. Positive numbers go up, negative numbers go down. You have positive numbers to the right of the 0, the origin. Negative numbers to the left of the origin. Positive numbers above the origin. Negative numbers below the origin. The same signs and directions apply generally to the vectors. That is the reason why I consider the 55 going to the right as a positive number and the 50 going to the left as a negative number. If your friend was pushing with more force, say 60, then the table would move in your opponent's direction. But that would require that they push with a greater force than you to overcome you. But you are pushing now with a greater force than they. They are pushing with 50 pounds to the left. You are pushing with 55 pounds to the right. So the table will move to the right and behave as if it is being pushed by 5 pounds. So you see that happening. These are vectors acting in the same direction and vectors acting in relatively opposite directions. But now we'll look at something else. We want to find out what happens when vectors act non-parallel. Let us see. We must erase first of all. Let us erase parts of our board. Then let us look at what happened in the next case. Let us say you are pushing on this table with a force of 30 pounds. And there's somebody right here pushing on the table too, but in this direction with the same force, 30 pounds. How are you going to deal with this situation? Remember now, you cannot just add these numbers and say 30 plus 30 equals 0. That will not work. You cannot add them, or 30 plus 30 equals 60, I should have said. That wouldn't work. You cannot say 30 plus negative 30, which is 30 minus 30, equals 0. You cannot add them like that. But think about it. Would the table move? And if it moves, move in which direction? You can see that it would move. It would have some movement up in this direction, and it would have some movement to the right, like this. In other words, it would take some path in this direction. Let me just add this vector here. It would move somewhere there. The resultant would be somewhere here. Well, let us see what happens to the vectors themselves. Remember, you have this vector and you have this vector. This is 30 and this is 30. Now, we will look at two methods that might be used to add these two vectors. The first method is called the triangle method. The triangle rule. To apply this rule, you must move the vectors. You maintain the same direction. Make sure they're still pointing in the same direction. And then you point them so that the end of one touches the beginning of the other. Now, I will give this 30 a different color. So this vector is acting this way. Let us call this vector AB. This is vector AB. And this one is vector CD. What you must do is move the vectors so that they follow each other and touch end to end, like this. It could be that way. I'll put my C, put back my C here. And my D will come up here. So, you should get the idea here. Next, you are going to form a triangle by drawing a third vector. It will start at the beginning of one and end up at the end of the other, like this. This will end up as the resultant. So in this case, AB plus CD is equal to AD. I must put my arrows over these. So, you see what's going on here now. This is what is called the triangle rule. You put the vectors so that the beginning of one touch the end of the other. You transfer them or redraw them. Maintain the size, which is the length of the lines, and maintain the direction. Don't change those. Arrange them so that they touch each other, the end to beginning. Then at the other ends of each, you draw a third line to form a triangle. Now, the third vector is the resultant. It is at an angle from each of the other vectors, which you can calculate using trigonometry. And the length, you can also calculate that using trigonometry. Now, let us do that. I want to move these items first of all. To find the length of this, you make a note that this triangle is a right angle triangle. So you should remember how to deal with this. You don't have to find any angles. What you can do is use Pythagoras theorem. Now, AB, what you have really is AB plus CD equals AD, but you have 4 letters here, you need only 3. Since B and C end up at the same place, I'm just going to drop B for now and say what we have is AB plus BD, and that will be equal to AD. So, here, you have AC, you have AC plus CD equals AD. Now observe something with me. Make a note that you could be very well walking around this triangle. This is you walking around the triangle. You are at A and want to go to D. You have two routes that you could take. You could travel from A to C, then turn the corner, go from C to D. Or you could go from A to D directly. So you see, you have a horizontal vector and a vertical vector. They add to give you the resultant vector here. But what we want to do right now is calculate the magnitude of AD. How do we calculate the magnitude of AD? Using Pythagoras, AD squared is equal to AC squared plus CD squared. So AD squared, whatever it is equal to 30 squared plus 30 squared. So AD squared is equal to 900 plus 900, which is 1800. You see that? Since AD squared is equal to 1800, question, what is AD equal to? Can you tell me? AD will be the square root of 1800. Remember that part. Let us use our calculator to find the square root of 1800. You could put it in basic mode for now. The square root of 1800 equals 42.4. To one decimal place, it is 42.4 units. So you see, the resultant is 42.4 units. Now, I had used Pythagoras theorem because this is a right angle triangle. But remember, if it's not a right angle triangle, you cannot use Pythagoras theorem. Now, I'm going to also encourage you to find these angles. It's going to be an isosceles triangle. You know this is 90 already. Find these two angles. And I want you to work this question, this answer out again by another method. When you find this angle, you will say the sine of that angle, it will be BAD. The sine of angle BAD is equal to the opposite, which is CAD, I should say. I have dropped B. The sine of CAD, the angle CAD, is equal to the opposite, which is CD, divided by, I should not use sine. Tangent, I should have said. The tangent of CAD, this angle here, is equal to opposite, which is CD, divided by the adjacent, which is AC. Use that method to calculate this answer. If you're having too much problems, let me know in the comment section. But I want you to do that for your homework. Remember, it could be any angle at all that forms this triangle. But let us redo this by using what is called the parallelogram rule. Let's look back at the triangle rule that we use, and then we come to the parallelogram rule. The triangle rule says we have this vector acting this way, this vector acting this way. We must move one vector. So instead of touching each other at the head or at the tail, the head of one touch the tail of the other. Then you form the triangle to get the resultant. But with the parallelogram rule, what the parallelogram rule says is that you form another vector equal to this one, then another vector equal to this other one. The resultant would be another vector that will leave where the two tails touch at one end and end up where the two heads meet. This will be the resultant. So if this is 30 and this is 30, notice this is 30, this is 30. You can find the resultant just like how you found this one. Because this is a parallelogram, not a triangle. But let's do a little thing here. Suppose we erase this part of the parallelogram. It's a smaller diagram, but it's saying the same thing. You notice you have a 30, AB, AC is 30, this will be AC, we'll drop the B, and CD would be another 30, so the calculations would be the same as this one. So remember now, the resultant is what you get when you add two vectors. When you add vectors that are parallel, you add them to each other if they're pointing in the same direction. One should be subtracted from the other if they're pointing in opposite direction. It could have been a case where one is acting that way and the other is acting that way. You add the numbers just the same. If this is 30 and this is 30, then the resultant would be 30 plus 30 for 60 units. That is what happened when they point in the same direction. If they point in the opposite direction, if they're going left and right, horizontal, you generally consider one going to the right as positive, the one to the left as negative. They're going up and down, the one going up is positive and the one going down is negative. If they're slanted like this at an angle or like this, then you can consider One of them positive, the other one negative. Whichever one you want, unless you're told otherwise. But generally, the one that seems to be going up and to the right is considered positive. The one that's going down and to the left is considered negative. Now, here, this can be considered positive and this negative. But you could switch them around. You could consider this one as a positive one and this one as a negative one, depending on the situation. You see that? So, when they're in opposite direction, you just take the magnitudes, the numbers, and subtract them. But when they are not parallel, there's an angle between them that is not 90 and is not 180, is not 0. Then you draw on your knowledge of trigonometry, such as the Pythagoras theorem in the case of right angled triangles, the trig ratios in the case of right angled triangles, the sine and cosine rule if they are not right angled triangles. So, we're going to be looking at some examples later on, but we'll continue this topic in the next video.